Today's video is the first in our probability unit and is about sample space. The objective of this lesson is to determine a sample space using an organized list, a tree diagram, or the fundamental counting principle. When we talk about sample space, we're referring to the set of all possible outcomes of an experiment. For example, if I have a six-sided die and I were to roll that die, 6 things could happen. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So our sample space is 6 outcomes. If I were to flip a coin, my 2 possible outcomes are heads or tails. So my sample space includes 2 outcomes. When we want to find sample space, there are 3 methods we can use: organized list, tree diagram, or fundamental counting principle. Let's start with the first method, the organized list. Using an organized list simply means make a list to organize the different possible outcomes. This is a great method when we know the number of outcomes is relatively small and when we need to know the specific outcomes. Let's say I have this 4-part spinner. When I think about using an organized list, I think about what is it that could happen when I spin the spinner. I could get a 1, I could get a 2, I could get a 3, or I could get a 4. So my possible outcomes are listed in order in brackets. My sample space then is 4 outcomes. Now here's one for you to try. I want you to sketch this spinner in your notebook. Use an organized list to determine the sample space and possible outcomes for the spinner. Press pause when you're working this problem, and then press play when you're ready to check your work. Let's look at another example. Let's say I have the same spinners in my first example, but this time we're going to spin it twice. If I spin a 1 on the first, I could spin a 1 or a 2 or a 3 or a 4 on the second spin. So I list those in order: 1, 1, 1, 2, 1, 3, 1, 4. I continue writing each possible combination in order. So what if I spin a 2 on the first spin? What if I spin a 3? What if I spin a 4? I want to make sure I'm listing them in order so that I don't miss any possible outcomes. If I add them all up, I have 16 possible outcomes. Here's one for you to try. I want you to use an organized list to determine the sample space and possible outcomes for flipping a coin 2 times. Pause the video while you're working this problem and then press play to check your work. Another method for finding sample space is using a tree diagram, which is simply a visual representation of the organized list. This is a good method to use when you're finding the sample space of more than one event and when you need to know the possible outcomes. Let's use that same experiment we had in problem 2, flipping a coin 2 times. When I want to make a tree diagram, the first thing I do is list the headings that represent the experiment's events: first flip, second flip, outcomes. Next, I list the possible outcomes of my first event or my first flip. I could get heads or I could get tails. Then I draw a branch from the outcome of the first event to possible outcomes of the second event. If I flip heads on the first flip, I could get heads on the second, or I could get tails on the second. I do the same thing for all outcomes of my first flip. So I heads or tails if I had tails first. Finally, I list the outcomes by traveling down each branch. I had heads and I have heads, so my outcome would be heads and heads. I have heads and then tails, my outcome would be heads and tails. I continue doing this for the rest of my tree diagram. Finally, I would count up my outcomes and see that my sample space for flipping a coin 2 times would be 4 outcomes. Now you try making a tree diagram. I want you to sketch the spinner and use a tree diagram to determine the sample space and show the possible outcomes for spinning the spinner 2 times. Pause the video while you're working this problem and then press play when you're ready to check your work. Here's another problem for you to try using a tree diagram. Again, sketch these spinners in your notebook, then use a tree diagram to determine the sample space and show the possible outcomes for spinning each spinner 1 time. Pause the video while you're working this problem and then press play to check your answer. The third method for finding sample space is called the fundamental counting principle. This is best used when you're just wanting to know the number of outcomes and not the specific or possible outcomes. For example, let's do that flipping the coin 2 times. Maybe I just want to know how many things could happen and now not knowing which specific combinations. So the first event I have is to flip the coin, and that has 2 outcomes, heads and tails. If I were to flip the coin a second time, I also have 2 outcomes, heads and tails. The fundamental counting principle says if I multiply those outcomes together, I will get the total number of outcomes. So 2 times 2 is 4. Flipping a coin 2 times has a sample space that includes 4 outcomes. I want you to try one. Sketch the spinner in your notebook. Use the fundamental counting principle to determine the sample space of spinning this spinner 2 times. Pause the video while you're working this problem. Press play when you're ready to check your work. I want you to try another one with the fundamental counting principle. This time you're going to determine the sample space for flipping a penny and rolling a 6-sided die. Pause the video while you're working this problem and press play when you're ready to check your work. The fundamental counting principle is really a great choice when the number of combinations are larger, so that you don't have to write a very long organized list or make a very large tree diagram. So let's say that Jay has 2 shirts, 3 pants, and 2 shoes, and how many different outfits could be made? Well, this could get pretty lengthy for an organized list or pretty large for a tree diagram, so let's use our counting principle, especially because we're not interested in knowing the specific outfits, just the number of outfits. So he has 2 options or 2 outcomes for shirts, the red one, the blue one. He has 3 outcomes or options for pants, the khakis, the jeans, and the black pants. He has 2 options for his shoes, either the black Vans or his red Nikes. If I use the fundamental counting principle, I multiply these together, 2 times 3 times 2, and that gives us 12 different outfits. So our sample space is 12. Now I want you to try one. An ice cream shop has 8 ice cream flavors, 4 toppings, 3 cone varieties. How many options does the customer have to order? We're not interested in the specific different combinations. We're just wanting to know the number of the sample space. Pause the video while you're working this problem, and then press play when you're ready to check your work. So in today's video, we were determining the sample space using an organized list, a tree diagram, or the fundamental counting principle. We'll see you next time.